Hello YouTube, Nate and Hurst here with Camp Power Sports. We're going to start part 5 of our video series on the 7mm alky build. What we're going to be looking at today, we've got kind of the first layer of grime and stuff washed off. We're going to be dealing with the case prep work for this build. So part of the cleaning process, and we did all that off camera, is chasing this the stud threads and getting ready to blueprint these cases for what we're going to do. So I just take, even if you don't have a set, it behooves you. This is an 8mm by 125. That's what these studs are in size. You can go to your local hardware store and just buy a single die instead of a whole set if that's all you're going to be using. But they work great, you know, cleans the glue off the threads, and if you have a bit of a bad thread, oftentimes you can restore it. You're going to be checking these studs to see that they're bent. These long ones oftentimes get bent. The goal here is to clean all the glue and everything out of the threads so things are working right for you. That's just part of the cleanup and the prep process. Oftentimes when we're doing other work, these studs get removed anyway. We will be pulling the studs on the bottom of the case. When I do the trench work on these cases, we're going to do it in the CNC machine. To avoid having a long mill, we'll pull the studs and have them out of our way. If I were going to be boring this for a larger cylinder, boring this area to accept a larger cylinder, which isn't necessary in this build, then we would be removing these studs on this deck as well. There's some other work involved with that. Maybe we'll get that on a future build. I won't go into those details too much on this one. We're going to be blueprinting this case. Even though these are stock Banshee cylinders, we're going to be using a Cheetah Cubs base gasket as our template for the port matching that we'll go over. And that's what we're going to do right now, is just kind of set this up for port matching. Another thing that you could get is the die cam. I'm not an advocate of brands, but this is what I happen to have, and I'm not soliciting any particular brand. You can color this deck with a marker, you can spray paint it, but these layout fluids are cheap, they'll last forever. They even make it in an aerosol form, so whatever brand, there's all different kinds of layout fluids. But we're going to want to change the stock porting here and look at our rooms where we can grow and also blueprint this case to the cylinders and to what we're doing. So I mentioned I used a Cheetah Cub gasket. Many of us in the Banshee world clearly know what that is, but what that is an aftermarket cylinder assembly that converts in the Banshee, converts from 2 individual cylinders to 1 monoblock. Is quite a nice product anyway. But we're going to use a base gasket for one of those cylinders as our template. And I'll just slide it on here right now, slide it over the studs. Using the gudgeon pins that's in your case still, all 4 of them, you're going to want to center this gasket to the case. You can clearly see right here what we're dealing with for our metal removal. It's a substantial gain for the amount of space that's available here, so that's a good, quick, dirty, at-home, do-it-yourself way to gasket match your case and blueprint your case, as well as getting some gains out of your areas out of it. It's a good way to go about it. So what we're going to do is use this gasket as our template and match those pre-designed surfaces, shapes, to both the cylinder and also here to the case. That one gudgeon pin's a little bent, so I'm being careful not to tear the gasket and gently walking it off those centering pins, those gudgeon pins. And okay, so you're going to take your die cam layout fluid, and you're going to paint where that removal was going to be, and you're going to allow that to set up and dry. Make sure you got good coverage around your ports there so you can get nice. You're going to essentially be scribing lines of that gasket shape in this, and that's why I said you can use permanent marker or spray paints and stuff like that. It's maybe not the best result, but it works, and we've all done it. So this layout fluid is really nice to use. It is imperative that you have an oil-free surface, otherwise it will just wipe off. Okay, we've got some pretty good time. It could dry a little bit longer, but that's good enough. So once you die chem your case, and I did forget to mention that die chem comes off readily and quickly with your fuel injection cleaner, your carb cleaner, those kinds of aerosols. Its cleanup is pretty nice. It stays when you want it when it's oil free, but cleans up pretty good. So you fit your gasket in place, and then take yourself a good scribe, and then just hold your gasket down and just scribe the outline of your port. And when you come back to port this, you want to just go up just touching the line. You don't want to overcut your line, but in any case, you're going to scribe all of your port lines out. Try to be smooth and delicate. You want to hold your gasket down and keep your scribing tool square so that you're not climbing at an angle and distorting where the line actually is. The plus side is if it gets too out of control on you, you can repaint it and start over. No harm, no foul. So with something as dark as die chem, especially against the aluminum here, you get a nice highlight when you're done. And if you transfer the line straight and clean and smooth, you get a concise shape of exactly where you need to be on your particular casting. I faced the print up, so you'll match that to the cylinders. Half thought there. When you do it on the cylinders, when you do the same thing on the cylinders, you're just going to keep the gasket oriented the same way so that the print's facing the cylinders, so they would be up, and everything will match. Even if the gasket's a little off, at least you'll have a matching assembly when you're completed. So at that point, that was all the prep needed for the top of this case. We can go ahead and go port at this point and match the case to those gaskets. When doing so, I prefer to leave your bottom shapes in this particular case similar to where they're at, a little bit wider down this wall to match this, but out here on this wall, about where this radius starts is where you want to gently taper this radius right here coming up the transfer. About where that is, half an inch, 5/8 of an inch down, is your height line where you want to start to transfer and pull that wall away and just radius it back to that outline. That will be a nice smooth transition without a lot of steps to disrupt anything and get you out to the bigger size needed. Keep in mind you may need to do some transitioning at the cylinder too, so it all lines up well. So kind of analyze what you have going on and suit it to your needs, but that's the quick and dirty way to get your cylinders blueprinted to the case, and also find a little bit of gains over the stock geometry really quickly using the components you're going to use, so it's blueprinted to exactly what you're doing. So our next step is going to be make sure I'm in the camera.
You are.
Our next step is going to be clean these threads on these studs and remove them so that we can address our mating seams and we'll go over that, and we're going to need to remove our gudgeon pins. These are cheap, so if they don't come out freely, a lot of them are stuck, and I'll get to those, so we'll see them better. Do what you can, and you get those gudgeon pins removed. Sometimes they're very, very stuck. Sometimes you can get them out and work with them. Oftentimes they're cheap enough. If they're compromised at all, they get replaced anyway, because they're the locating pins to the assembly. We'll get to that, and we'll have a better view of that when we get that far. But we're going to strip these cases down, get these studs out. If you do not need to remove these studs, leave them there. This job can be cantankerous. A lot of people break studs. Unless something else is going on, we usually get them out with no problems. I am going to use the double nut method because that's what's available at home. I'm going to use tooling that's available in the home shop. You don't need to go out and buy a nice Snap-on or Blue Point or whatever brand of stud puller set to do this. Although they do make the job nicer, we're going to do it as if we were at home, limited on tooling. So we'll move forward. I'll get this other case half out of my way, and we'll move forward and begin the process of removing these studs. It begins with the same thing on the top, chasing your threads, cleaning the glues out with the tap and die. And we'll go through and do that on all 8 of them. A pair of quality 12mm wrenches and a pair of OEM nuts. I have had the best luck with the OEM flange styled nuts for doing the double nut method. The hardware store nuts are oftentimes too soft of a metal, not enough surface area. Those are the ones you always pull the threads out of the nuts trying to do what we're about to do here. And you will, with the Banshee, you are going to need a MAP gas torch. Propane will work, but it's not as hot and it's not as friendly to work with. We'll go ahead and get started here. So put a wrench on your stud, put a nut on upside down. I'm sure many of us know how to double nut a stud, but we're still going to illustrate it for at least one of them. Put your other nut on the correct way. I run this nut down until it's just to the start of the thread. This is one of the harder studs in the case too, because it's one of the longer ones and flexes. And sometimes you're going to hurt a nut, but if you work slow and work right, you won't damage the stud, and you can feel this way if it's going to break. So what I'm doing is I'm tightening the 2 nuts against each other. Nice scissors action creates an extreme amount of leverage, squeezing it like pliers versus just pulling on them normal. Now, for a fulcrum, I turn the case sideways and support these long studs. They oftentimes need to be bopped, but you heard it on that one. It came loose that easy. Now you can take your cordless or your air tool or by hand and extract the stud. It really is that simple. If they're stuck, you can find the bosses in the casting, the threaded hole, and apply your heat to it. I'm going to go ahead and move forward. Let's repeat that procedure to remove all those studs. I'm going to go ahead and move forward. If we stumble on a stuck one, I'll come back on and we'll heat it and show what we do there and show some of our tricks with oiling. Okay, we'll be back. Okay, these ones are coming out pretty easy on this case. So I just figured I would show when they are easy. To speed up, put your wrench on the bottom, grab your power tool, run it down, let it hammer a few times. Move your wrench, keep going a little bit, and back the stud out. Looks like that's how most of these studs are going to be. So I figured I would just show it a couple times this way. We'll see what happens on this longer one. Generally, a couple of these are pretty stubborn, and I was hoping to be able to show the fight, but these ones are doing us a pretty good favor. We'll try this long, flexible one right out. So that's just, you know, I thought I'd throw that on there. Okay, now we've got all of our gudgeon pins out. Our gudgeon pins. We've got those removed, and we've got all of our studs out. So what we're dealing with now is our completely flat surfaces. Again, we do this part with our mills and with machining, but for home use, I'm going to show it what we can all do. You can get these supplies secondhand. It's going to be a granite slab, 400 grit sandpaper, wet dry sandpaper, some material adhesive like the 3M fabric adhesive, spray on fabric adhesive, but we're going to make a lapping table so that we can lap these seams. Now the goal here is, and I have to reiterate, because on this style of engine all your bearings are on the split seam of the case, so all of these dimensions are critical for the diameter of your different bearings. So you are working delicate here. The goal is to take care of, you know, in the past people maybe have separated the case with a screwdriver and nicked this surface, or a hammer's been used in the wrong area and bulged a surface because it dented. So basically you're just going to ensure that your surface is flat. If you need to do any form of repair work to these mating surfaces, for the most part it's above the scope of what we're going to talk about. It requires machining, it requires line boring to restore these bores in these seams back to round and the exact dimensions. So basically we're going to be dressing these cases, not repairing them. We'll be back, we'll get set up over at my granite slab and we'll go through that, and we'll take care of both these mating surfaces on this case. Okay, here we are. Now, as you can see, mine has a lot of hours on it, but this granite right here, synthetic granite, is just from a cabinet installing shop. It was just a piece of scrap. Sometimes you can find these guys to give it to you. It's almost useless to them. Works great. Some 400 grit wet and dry sandpaper, and some fabric spray adhesive. So these granite countertops are flat enough for what we're doing. You'll read a lot of places, paste and glass. Yes, but unnecessary. We can get done what we're doing this way, and it's quick and effective, and it works well. So, you know, I do a lot of dressing on this plate, and it works great. Basically, you just 3M spray. You know, I say 3M, but spray adhesive your plate. Spray adhesive the back of your sheet. Follow the manufacturer's instructions on the glue. Let it get tacky and lay it out clean and flat. And an old junk rolling pin, an old wrist pin, a socket, a bar, whatever, you can kind of roll it out. Make sure you're bubble free and get it down nice and flat. Once it is, it stays there. Again, carb cleaner, brake cleaner, any adhesive dissolver, gasket remover, spray gasket remover, and you can peel this off, scrape it with a razor blade, clean it, and start over. So as you can see, my paper, it's probably about 1,000 grit. It's pretty worn. But again, we're not trying to take a lot off these cases. We're just dressing them, trying to find any of the sneaking highs, the screwdriver pry, the little dent, anything that would potentially on a normally good looking case surface, anything that would potentially hold it high right here and cause a leak. The glue that you use on these cases is thin and flows, and so there isn't a large tolerance window for surface imperfections. So you want these surfaces cleaned and blueprinted. So to some, it's not worth it to mess with the studs. I do it often. I do it on a lot of cases. Sometimes you can find a little nick, take a razor blade and dress it, you know, and work with it that way. So maybe this is a little overkill, but it's clean, and in my opinion, a good way to start a good foundation of a build. Your prep work and your cleanliness is the most key thing. This is just plain old water, wet and dry sandpaper. You'll read other places, WD-40 and everything else. It works well, it cleans as it cuts, plugs your paper immediately. So, just depends on how often you want to be changing this paper. Figure eights and X's, never same direction, and let the weight of the case or whatever the part is be your dictator. You don't want to push down, because you can't push very evenly, then you will begin moving material at rates that are uncontrolled. You'll begin making angled surfaces. That's not the goal here. It's just to dress it, see what you're up against, and condition it a little bit. So some nice figure eights. The first part happens fast. I will rotate around, maintaining that figure eight configuration. Maybe even count cycles, 4 or 5 sweeps and a rotate. Again, I'm not really pushing down. I'm letting the case do the work for me. Not a lot of action is happening here, but your highs are found quickly, and any of your nicks are found quickly, and surface imperfections. So let me grab a rag. Okay, we'll work on zooming in and getting a good light angle so that you can see what I'm seeing well here, and then we can go from there. Okay, before we roll in, we can kind of see it here. The cleaner that I use, if you let it sit too long, will kind of blacken the cases a little bit. That's what this is right here. That is where some of that cleaner ran down and blackened the case a little bit. Up in here, we've already got a tooth showing up from the sandpaper, so we know that we're down in the front, but since we can see that discoloration, we know we have a void in here, and we're not perfectly level. Now if we go after this and try and make it level, this isn't as torqued, so these cases can flex and crawl around a little bit, and if you make them perfectly level now, all unloaded and unsprung and not bolted together, you may be introducing a problem, especially if it takes enough material removal off of your high surface that's already on the paper to get to this surface. You may create a situation that when you torque your fasteners, you'll squeeze these bearings and pinch them, and because you've taken the clearance away out of the bore. So it's a judgment call, and then when you look at your torque pattern, it starts here, and this case is intended to be pulled up into place to a degree. They should be flat, but the point is you're not trying to remove everything, you're going after all the highs. Okay, here at the back half of the case, I hope I got it in the light, we have our crosshatch from our figure eights all the way across and all the way up in the back half of the case. So that one spot was our only low spot, but anymore we can do just a little bit, but I can take my finger and go all around this surface and not feel any nicks or dings that's going to hold it high. So for all intents and purposes, that's done. That's all that was necessary. I'm going to go ahead a little bit more on this one, and then we'll do the other case half the same way. Okay, this is the other half of the case. I wanted to point this out. I don't know how well the camera's going to zoom in on it and reproduce it, but right here was a nick and a high spot by the bearing. As a result of that, we're touching in the front of the case, touching in the rear of the case. We're not touching over here, nor by the transmission bearing, which is off the screen right now. But this high right here affected the whole center of the case. I've got a nice positive crosshatch, and outline the dent of it, and I can slightly fill the transition. So a little bit more on this case to walk that down, but that's the whole point of this, is to find those high spots and take care of them so that that magical air leak doesn't show up on you. Nothing's more frustrating than getting done with a brand new complete build and find out that you're drawing gearbox oil into this cylinder because there's a case leak in this seam right here, and it's sharing the transmission to that cylinder, or worse, or as bad, however you want to look at it, having it over on the side of the engine and introducing a fresh air leak to this area of the engine and causing your jetting to be a headache, and or a burnt cylinder because that side was lean on a normal, and you can chase that with your jetting a lot, and sometimes these little parasitic leaks won't cause the death of an engine, but can make you sure chase your tails dialing in an engine on the jetting side. So in any case, this little dent, and I hope it shows well, but this little dent right here is exactly the type of stuff we're looking for with this process. I prefer this method because it finds it. It doesn't rely on you having to see it or feel it. Anyway. Okay, I went a little bit more and turned it sideways to see if we could just see a little bit of a different view on it and see if it was better. There's a dull smiley face right here. That is the low that was caused from whatever happened, but you can still see the factory machining here combined with my sandpaper tooth, and the factory machining here as well as right here. This spot of it, that spot of it I just colored was the high point. That's what was holding it up. There is also another one right there. So again, you can see the stain right here from the cleaner that blackened the aluminum a little bit, and that kind of worked in our favor too when it blackened the aluminum because it highlighted the highs and lows. But I cannot feel at all with my fingertip where I've colored. Before doing this, I could feel a slight nub. So the point is we got it just flat because the area around the low was scrubbed shiny by the paper, as well as the dent itself. You can't feel a rise or a drop to the dent, but the stain was still around the marker, showing the little bit of low that was there. You don't want to dig it all the way gone. You just want to take that high spot, the part I colored with the marker, down flat, and you're good. You haven't changed any dimensions per se, and you haven't put anything at risk without having proper measuring tools to address all the bores and everything, and everything will come together nicely. Okay, so the cases are dressed. It didn't take long at all, a few minutes, and well worth the time spent. You can do a couple other caretake items at this point. For example, these oil holes that feed the crankshaft, you can soften their edges a little bit. They're really sharp how they drill through, and you could possibly improve some of the oil drain back. The next part we're going to move on to is the actual act of trenching it for the 7mm stroke. So we'll go back to the other part of the bench. I'll get the crankshaft out we're going to use for this engine, and in the crankshaft series we will be modifying and setting this particular crankshaft up for what we're doing, and I'll explain why we do what we do as we get there and address some of the bearings and also some of the diag stuff to look for in a crankshaft. A lot of guys are having aftermarket cranks crack the welds on the pins, and I think the real reason why the problem exists is being overlooked to a degree, but we'll get into that when we go over the crankshaft. And I won't go too in depth there. I don't know how many home guys are building crankshafts at home, but if you own a press you can do it, so with a few things taken care of. long story short, we'll grab a brand new crank here. This is a 7 mil crank. It's a forged crank. We'll go over that too. But if I carefully put the crank in the case, the back of the rod hits. There, it will not clear. It will not go all the way down in the case. So the case needs to be milled to accept the back of the rod here, to allow it to index in. The back of the rod here is protruding past the diameter of the crankshaft. So there it is right there. It's hanging out past the outside of the crankshaft. It's going to smack on the case, and the case needs to be machined for that clearance. So we'll go ahead and move forward and determine how much we need to mill this case in order for this crankshaft to fit. Okay, first of all, the disclosure. I realize a lot of people don't have some of this tooling at home, and sometimes it doesn't constitute purchasing it for the one time you're going to do it. So this type of procedure is probably, for a lot of people, is something that you're going to want to farm out and find a shop or a machine shop that can help you out with that. We offer this service. Again, it's all done, controlled in a CNC machine. We know that our cuts are accurate cuts. The metal that we're removing is an accurate amount within a tolerance window, and the results from cylinder to cylinder are much more controlled that way. If you're going to farm it out, the rest of this doesn't matter. You know, just choosing the reputable shop is enough of a task in itself. Again, we do offer this service and can definitely take care of you in this department on many different styles of engines. This is a crude way to get it, but you're going to measure what that protrusion of the rod is, and roughly 83 thousandths on this particular setup right here. But you're going to need to build it with a specified amount of clearance to that amount that it hangs out. So when it's all done, this crankshaft can bow and flex around. We're going to get into that a little bit and just really briefly talk about the crankshaft, and then we can move on and we'll get to the fun part, actually getting this thing in the mill and milling it. Okay, this crankshaft assembly is a pressed together assembly. Each of these pieces are individual pieces. The pins for the big end of the rod are pressed into place. The bore is retained. A lot of companies do a little weld right here to help pin them. First of all, let me clarify that weld. That weld is not structural. They're dissimilar metals. That weld is to help lock. That weld should be considered nothing more than Loctite in a regular bolt and nut application. That weld cannot and will not hold this crankshaft assembly together. This pin fit is very, very crucial. It's very important that the hole that's in this crankshaft web is slightly smaller than the diameter of that pin, and that's a controlled, tight tolerance fit that has very little mercy to it. Too tight of a press fit and your crankshaft web can and will crack right here, and you'll break open the crankshaft web. Too loose of a fit and the inevitable happens. And the reason I stress a weld is not to hold a crankshaft together. If it's too loose of a fit, then this web is free to rock a little bit extra that it would normally be able in a normal press fit. So the punchline of what I just said is, if your interference fit is compromised, the best weld in the world is still going to be worse off than a properly fitted press fit. And we see this in the Banshee world, over the snowmobile world, and many other press assembly cranks, we see this problem with the Banshee the most. There are, because of popularity, there is a huge aftermarket for these crankshafts. Quality control is key. If you want the best for your money, then I'm going to suggest a billet crankshaft at the expense of some weight, because the quality control is held much tighter than a lot of these aftermarket companies producing these crankshafts and importing them. We get titles on these crankshafts: Wayne crank, Chinese crank, whatever. Generally, the castings, the forgings don't fail. We've seen where a crankshaft snout is busted off. You could maybe blame an out of balance flywheel. We've seen the center pins bust. Everything's going to break. In the snowmobile world, we see a lot of big end bearing pins snapped right at the web because everything fit well, and the next weakest point was the pin itself. There's a several year window on a particular 800 where it was like clockwork. At a given mileage on the sled, it was broken right there. So we see that a lot. Welding these crankshafts is not going to help any integrity of the crankshaft. If this pin bore is compromised, then the crankshaft is compromised. There's a lot going on here. So when it comes to the mainland China cranks and all these cranks that get beat up, your biggest problems with them in general are due to quality control. First of all, the pin bores could be compromised in the interference fit. And second of all are these bearings. They are a loose fitted cage able to turn some RPMs. They're kind of a, in my mind, on the engineering level, they're a band-aid bearing. They're fit loose in their assembly so that they can turn fast without a lot of friction. These bearings are a little substandard for what we're doing. I won't go into depth on the bearings, but long story short, in order to get a quality forged crankshaft, none of the companies that are outside of the USA billet companies, none of the companies that I've found nail it in all of the departments of tolerances and run out and things like that, and component quality. These rods are good for art projects in the garbage can. I will not put these rods in my engine. They break right here like clockwork. I'm not going to mention the brand of the crank. It's irrelevant. These rods are proven to be inferior, especially when you're doing modifications and building any level of power, which is the point of stroking your motor, right? So, right out of the box, the only way that I will sell or send a forged crankshaft out of this shop is if I grind these welds, push it apart, throw all these bearings and these rods in the garbage can, and start over on this foundation with quality parts. At that time, I can accurately measure these pin bores and measure these pins and address any incompetencies in the assembly line quality control to ensure that it's going to be a reliable part. If the pin bores are tight, the parts are quality, the assembly and the runout is quality, you stand your best chance. Doesn't matter if it's forged, doesn't matter if it's a machined crankshaft from billet steel. It comes down to components and assembly quality, and the best crank will not last any amount of time. The best components cannot last if the quality control and the assembly quality is substandard, let alone, you know, some of the questionable components doing well for you. It better be assembled perfect. A crankshaft is something that cannot be compromised, especially on that runout. The act of pressing all these components and keeping this center line axle established through the assembly, that runout is the maker or breaker of any engine. from here on out, for the rest of the video, for most of you, this is going to be an area where you're going to seek the services of somebody that already does this. It's not going to be worth it to try and tool up and learn all this for one engine. We'll provide the link in the comments for our contact info. This is a service we provide, and it's no stranger to us, and we're fully tooled to be able to do this properly. So the next step of this video, we're going to go ahead and move forward, and we'll get the cases in the mill and maybe show a little bit of the process of milling. Okay, we got the trenching all done, and we're sitting here on the bench outside of the coolant. We'll just give you a little close-up of what the finish is, and then I'll show the crank in place and talk about the circlip that locates the crank. Alrighty, now before we set this crank in, all the trenching's done for the 7 mil. As you can see, it was all very controlled and consistent. I want to talk about the circlips on the crank for a second. The factory circlip that locates the crank is just a half round. We've seen a common trend show up that's an absolute mistake. When people order an aftermarket bearing and install it on the crank, like the nickname Max Load or TZ, it comes with this full circlip. It's been trendy that people think that circlip is better and they leave it installed. That's an absolute no-no for one reason, and I'll tell you why. Now these are just cheap calipers. If you measure the cross section of the full circlip here, I get 154 thousandths, 0.154. Okay? If you measure the stock cross section of this circlip, the stock half round, it's 138 thousandths, 0.138. So you are almost 20 thousandths of an inch larger in diameter with the full circlip than you are with the factory one. What happens because of that is when you snap this on the groove in the bearing and stick it in the case, it doesn't collapse tight. It's too big in diameter. So what happens is when you torque your cases together, it puts a clamp on the bearing and causes a premature bearing failure. It clamps the outer race on the bearing, pinches it, and causes a premature bearing failure. So unless you're going to dress this one and make it the same dimension as the other one in the circumference, the better thing to do, which is the equal result, is get an extra OEM clip and install them so that the seams are opposite the seam of the case, like such. Your seam's up here, right there, and then you can get the full effect of the full circlip. Now bear in mind, look in your cases before you order it, because some of the older cases do not have the groove machined in the top half of the case. They're designed for only the half round there. So this one would be useless to you there anyway, unless you cut the groove and had the groove machined in the top of the case. But anyway, I just wanted to point that out. It's a common mistake. We're seeing it everywhere. We're seeing a lot of crank failures because it looks like a good idea. But quite simply, this section here on this circlip is quite a bit wider than the cross section of the factory circlip. So it's too big in diameter and it doesn't work without modifying either the case or the clip to get the right clearances. Okay, now that that's cleared up, we'll go ahead and throw a locating clip in the case here, and we'll drop our crank in and see how we did. Alright. push the O-rings tight. Now where you're going to want to check this, I know we're good so I'm not going to bother. Where you're going to want to check this is take and put the rod right there at the case seam and stick your feeler gauge in right there to ensure you have the proper clearances. The amount of clearance is ambiguous. People have different opinions. Different cranks flex different amounts. We'll talk about that in the crank section. But long story short, as a rule of thumb, I believe that your minimum clearance should be 20 thousandths. That allows for some rock. We are more on this engine than 20 thousandths. We actually went and we have a different reasoning for our depth of our groove, and it has to do with volumes in the engine. That could be a whole nother video in itself, so we won't get into that. The point is, stick your feeler gauge in here, 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 and here, and make sure that you have sufficient clearance around the radius. And because this was done with a CNC machine, we controlled our step over amounts with the cutter, our tool depth with the cutter, and we held this to a constant despite any variations that may have been in the casting. So that's the nutshell of what goes on with trenching, and that's what's necessary to get your different stroke cranks to clear in the case properly. With that being said, we just have to wrap up on the gasket matching of the top case, and we're ready for another cleanup of the cases and hopefully to start the assembly process. Of course, we have to address the override transmission before we can put this together, so I guess after porting the cases we'll do a video on transmissions. Okay, thanks for watching. This is Nate and Hurst with Cam Power Sports. We'll see you on the next video. Please make sure to like and subscribe and comment on the YouTube. It helps make all this worth our while. And let's get the likes up there and spread the word. So you can find us on Facebook as well. Cam Power Sports, K-A-N Power Sports. And we'll talk to you later. Thank you. Okay, we're going to wrap up this video, but like I mentioned earlier, when we addressed blueprinting the top of the case and using the gasket to match the surface, we would give a little bit better view of what the porting looks like. This video has already gone a lot longer than we planned on. There's a lot to cover, and we're going to try and keep them short, so I'm not going to do any of the porting on the camera, and we'll conclude this video. I'll show a little more clips of it done. There's going to be plenty of chances to see the port work there too. So that's about, this is the center of the case. That's about the amount that it needs to come out to do the gasket match. So you can see there's a substantial potential here. So we're just going to walk that out just to the line and not past it, and blend it, and it should line up perfect with the gasket, and then we can do the exact same on the cylinder. Okay, for the sake of moving along, I just grabbed this other case that we've done in the past. This one's a repeat customer also. This one's a Super Cub, so it's been bored here and here as well as what we are doing to the 7mm. It's almost the same procedure, so I just thought I'd show a picture of this one to give the visual. A few of the details are different. Again, this is a very opinionated area, and lots of people do different stuff down below here, but I prefer, because of velocities, I prefer the higher case volumes, lower case volumes, excuse me, and the higher velocities. So everything's a gentle contour. I will just get a couple zoomed shots so that you can see and get a good visual of what goes on here. Alrighty, well, we appreciate all your time, and like I said, we'll try to keep the video shorter. This one went way longer than we anticipated, but again, there was a lot to cover. Once again, please subscribe on the YouTube channel. It helps us out, and make sure to leave your comments. We'll see you in the next video.